new EQ, and then pretty easy journal to answer. Raul, are you here? Did I miss you? All right, I'm going to take that as a no. All right, and so this would be an example of a journal that if you took it whenever we have our journal test, that you would want to answer it in a complete sentence to get credit. My favorite season of the year is fall, and then why it is. All righty, if you will go into your Google Classroom. Okay, you got to put all that up. I know, this is for my. Okay, but the quiz has time. So you want to go up here and leave all that and take the quiz? You're good? Yeah. All right, sorry about that. So if you go into your Google Classroom, and you go down under quizzes, you should have average atomic mass quiz. And if you'll give me a minute, I need to open them up. There's one of them open, and there is the other one open. All right, so they both should be open. Under quizzes, you have 10 minutes. I will set my timer to take your quiz. So in Google Classroom, look under your quizzes section. And take your quiz. You got about 9 minutes left now. Make sure you use your units and round appropriately.
Miss Lowry, my screen is...
Jasmine, please turn your camera on for me.
I've been having problems with the camera all day. Like, I'll click it and it'll save at the time, but it's not on. And the quiz isn't popping up on my quizzes thing.
I thought you shouldn't need that. Angel.
Oh, you don't
Yeah,
need that?
no, you don't need that.
Oh.
Not for average atomic mass.
No, the quiz isn't on my thing.
You might need to refresh it.
I tried like 3 times, and the most recent one that is showing is the subatomic particle one.
To say what? I'm sorry.
Like the subatomic particle, that's the most recent one that is showing.
Okay, let me go.
Miss Lowry, my screen is half black when I click on the test.
Okay, Jasmine, if you'll refresh and see if it'll come up now.
Miss Lowry, do we write AMU at the end or no?
That's a question you should not have to ask.
Okay, it's working now.
Let's see, yours is working now. Okay, well, what did you want to do? Okay, let's see. That's on your end with your internet. I don't know what to do. Samuel, the quiz is under quizzes. Quit asking me about retesting or requizzing. Samuel, if you go down to quizzes, it should be in that. Yes, it's locked on this for these laptops. Samuel, refresh and check again, please. All right. So once again, dimensional analysis process, or it's just it's a process by which we do conversions. And we'll be using molar mass and Avogadro's number to do these conversions that we're looking at right now. We talked about the fact that 1 mole has 6.022 times 10 to the 23rd atoms or molecules or formula units in it. All of those are different kind of particles. The number doesn't change, just the noun changes, depending on if I'm just talking about an element or if I'm talking about a different type of compound. If I pick any element, in this case, I just happen to pick aluminum, I can look on the periodic table, and the number that's on the periodic table tells me how many grams are in 1 mole of that element. It also tells me how much 1 atom of that element is in AMU. We also know that there are 6.022 times 10 to the 23rd atoms of aluminum in 1 mole. Remember, that was called Avogadro's number. So all of those different things can be used as a conversion factor. When we use something as a conversion factor, like when I use molar mass as a conversion factor, molar mass is grams per 1 mole. If it's just an element, it's going to be the number I get straight off the periodic table. If it's a compound, then we'll have to do some math to get those grams. But it's always per 1 mole. So that means that I can use this as a conversion factor, and I can use it this way, or I can flip it if I need to make it fit into dimensional analysis. So if we're talking about particles, we would be talking about atoms if we're just dealing with element. Excuse me. We would be talking about molecules if we're dealing with a covalent compound. And we would be dealing with formula units if it's ionic. These 3 are just different kind of particles. And it's if you see the word particle or you see one of those 3 in the word problem, that's a hint to you that you're going to have to use Avogadro's number. Because using Avogadro's number is then the way we can take those different particles and convert them to grams or convert them to moles. So the mole has been defined as 6.022 times 10 to the 23rd atoms of a pure element, or the molar mass of a substance in grams. If a compound, if we had to add those up, if it was just more than 1 element. It is also defined as 6.022 times 10 to the 23rd molecules of a compound, or diatomic molecules. The diatomic molecules are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Those elements, those 7 elements, are not stable as a single element. Okay. Which means whenever they're part of a compound, they're stable, or if they combine with a like element, they're stable. But you'll see in a minute, whenever we do a word problem, that can affect the molar mass. Because when I talk about bromine, it's not just the molar mass of 1 bromine, it's the molar mass of 2, because that's how they exist. These are something that you would want to memorize, the diatomics, because we use them the whole year and they come in and they affect some other things. So it'd be worth your while to memorize them now. All right, the next thing is a mole map. So I'm going to show you the process of dimensional analysis, which some kids struggle with. So they may choose instead to memorize this mole map, and this could help them move between things. So let's say that my known was that I had so many grams of something, but I wanted to convert that to moles. So if I wanted to go from mass to moles, then I would need to follow this arrow, which means that I would take my mass and I would divide it by the molar mass. And that would get me to grams. Or let's say that I knew how many moles I had of something. This was my known, and I wanted to figure out how many particles was in that many moles. Then I would follow this arrow. And I would take my moles and I would multiply it by Avogadro's number. So that's how the mole map works. One way you're going to be multiplying, the other way that you're going to be dividing, and this tells you what you are multiplying or dividing by. Don't worry about the ideal gas law. We'll get to that one later. So mole map is one way to try these problems. And then the other one is dimensional analysis, which is what we're going to look at now. And then you'll kind of have to figure out what works best for you. All right, so we go back and we're going to start doing problems with a given that came from some kind of measurement. So we have to go back and start worrying about our Sig Figs. And those come from the given. So in this problem, these are gram to mole conversions or mole to gram conversions. So that means I either know my grams and I want to convert those to moles, or the other way around. In a word problem, when you see grams or mass, that's a hint to you that you're going to have to use a molar mass as a conversion. So whenever we set up our dimensional analysis, it's kind of a little box system. Some people call them railroad tracks. Right now, the ones that we're doing are just 2-step. I'm calling this 1 step and this 2 steps. And then on Monday, we'll get up to some that are actually 3 steps. And then stoichiometry, we get up to some that are 4 steps. But when you start off this process, your given always goes in this first box. So my given is that I have 120 grams of calcium. And I want to convert that to moles. We're not putting anything in the box below the given. Angel, you need to be taking these examples down. And you follow your units. If I'm grams of calcium here, I need the same unit down and diagonal because I need it to cancel out. I want this to be my only unit I'm left with. So if I'm grams of calcium here, I have to be grams of calcium down here. So once I have grams over moles, or it could be switched, and this could be the other way, but once I have grams and moles in the same box, that's where a molar mass goes. 1 always goes with the mole part, and grams is where you would put your molar mass. In this case, grams for calcium is straight off the periodic table. I don't have to do any work on that. So I would get 40.08 grams of calcium. So you've done all your setup. Now you just need to, when you do dimensional analysis, you multiply across, and then you divide by anything that is on the bottom. So I would do 120 times 1 is still 120, and then I would come back and divide it by 40.08. So 120 divided by 40.08, and it can only have 2 Sig Figs in my answer. I would end up with 3.0, and these grams cancel out, and I'm left just with moles, so 3.0 moles. Now, if we want to go back and we want to look at that mole map, we can see how we would also use that. And like I said, it's just going to kind of be up to you which one you like better. On that particular one, I was given 120 grams, and I wanted to know how many moles. So I would have followed this. So I would have done my 120 grams, and I would have divided it by the molar mass. And once again, the molar mass would have been 40.08 because it was just for calcium, which is what we did. It's just a different way to set it up. Once again, grams cancels, and I would have come up with my same answer. All right, hold on just one second. All right. All right, so we'll look at the next one. It says how many grams of sodium are in 5 moles, and we're not going to do sodium chloride. We're just going to keep it a little simpler, plain sodium. So how many grams of sodium are in 5 moles of sodium? So my given is that I have 5 moles of sodium, and I want to convert that to grams of sodium. So I'll follow my same process. If I moles of sodium here, I have to be the same unit down and diagonal. And then it's just coming to affinity. And once again, I have moles and grams in the same box. So that's the molar mass. 1 always goes with the moles, is sodium as element. So I can get that off the periodic table. 22.99 grams. Moles cancel like I wanted it to, and then I'm just going to multiply across. 5 times 22.99 and divide it by 1, wouldn't change it. My original measurement had 3 Sig Figs, so my answer can have 3 Sig Figs. So you would end up with 115 grams. If you notice, when I have moles and I'm converting to grams, that's whenever I multiply and the number increases. If I have grams and I'm converting to moles, then it goes the other way around. It's a division problem and my number would decrease. All right, we'll look at a couple more. How many moles of lead are at 210 grams? And once again, I'm going to keep it simple. Take it out of the lead oxide and just say lead. So there's my given. 3 Sig Figs. Once again, I see grams, so that tells me I'm going to have to use molar mass as a conversion. And there's my unknown. Grams, and I want to convert it to moles of lead. So if this is grams of lead, I've got to have the same thing down here. Yeah. The 1 always goes with the moles. The PB, straight off the periodic table. Down here somewhere. 207.20. Once again, I'm going to multiply across. 210 times 1 is still 210, so I come back and divide it by 207.20. We said 3 Sig Figs. 1.01 moles, which makes sense because this is the mass of 1 mole, 207.2, and I had 2/10, so I had a little bit more. So my answer makes sense. All right, I wanted to show you one using a diatomic. So that's going to be the next one. You have it on your paper at the bottom, the one talking about nitrogen. It's not on this slide, but I'm still going to work through it. So on the very bottom, it says, how many moles of nitrogen are there in 44 grams of nitrogen? So I have 44 grams of nitrogen, and I am interested in how many moles of nitrogen. Nitrogen is diatomic. So when it's all by itself, you have to have 2 atoms attached. That's why I'm writing it as N2. So I start my same way. I start with my given. And I want to convert to moles of N2. Follow my units. If I'm grams of nitrogen here, I have to be grams of nitrogen down here. Moles, grams, so that's where my molar mass goes. 1 always goes with the moles. But now, because nitrogen is diatomic, that's 2 atoms together, instead of it just being 14.01, which is the mass of nitrogen, I have to use 2 of those. So I end up with 28.02 grams per 1 mole. My units cancel, multiply across, 44 times 1 is still 44. Divide by 28.02. 3 Sig Figs for my 44s. I would want 3 Sig Figs in my answer. 1.57 moles. All right. Anybody have any questions on that? I know it's just right now. You're gonna have to just jump in there and give it a try. There's practice online. It also involves using Avogadro's number, which we won't get it to until Monday. And so when you get to those, if you see a problem that says anything about particles or atoms, molecules that we haven't done yet, that we'll get to on Monday. So next week on Tuesday, you'll have your molar mass quiz, and then we'll have the test over this unit on Wednesday. And I probably should have tutorials next Tuesday, Wednesday, and Thursday is my plan right now, unless something comes up. Does anybody have any questions for me? All right, well, if in your Google Classroom, if you'll look in there, there is your practice that you can work on over this weekend, and also work on your practice over molar mass. And I will see y'all on Monday. Y'all have a nice weekend. If you need anything from me, you can let other people get off, and I'll hang around for a minute if you need to ask me a question or something, and you didn't feel like doing it in front of the whole group. Look hard or easy, guys? Huh? Did y'all pick y'all up in practice when you came in? Angel, yeah, that's the practice, and y'all won't have to. Okay, I guess nobody had a question for me.
Are you gonna like make some molds, like flush molds?
Actually, there is something called mold day,
Yeah.
and you can make your own mold. Yes, the numbers in parentheses are your answers, so you can check yourself.
So have you ever seen Lowry before in person
No, sir, I haven't.
if it evaporates and it's dead. I've seen some listed for some samples made, and they have to ship it by land mail, not by air, because of what it's like, the rates. Sorry, which state are you from?
I'm from here.
Are you from?
Mhm. But yeah, Crystal, you just got to kind of jump in one and start. It's one of those things, after you've done it, they start to make a little bit more sense.
How different was the periodic table in the like the mid to 19,000s?
Angel, why don't you work on some of your practice that we just learned?
Yes, ma'am.